Okay, if you turn to page 2 in your new chapter 4 packet called Functions and Linear Equations, okay, you should have picked this up at the main office. So on page 2, now if you didn't get it, you're going to have to print out page 2. The link is in the stream. Okay, so this is page 2. And on page 2, they show you a coordinate plane. And we are going to go over the coordinate plane. Now, the coordinate plane is created by drawing your x-axis. Your x-axis looks just like a number line. And then drawing the y-axis. And we know that's the y because it goes down like a y goes down, okay? So you have your x-axis and your y-axis, and together they form the coordinate plane. Where they intersect is the point 0, 0, and we call that the origin. Okay, now when we draw a coordinate plane, we create 4 quadrants. This is quadrant 1. Quadrant 1 is the quadrant where both x is positive and y is positive. So anything in quadrant 1, both x and y are positive. Now, quadrant 2, this is where the x values are negative, but y is positive. This is quadrant 2. Now, often when you see these quadrants, you see Roman numerals. So I'm going to do it both ways. You should try to remember the Roman numerals, but if you write regular, that's fine with me. Now, down here is where y is negative, and over here is where x is negative. So quadrant 3 is where both x and y are negative. And quadrant 4, that's an IV. Think of, I want to get into Ivy League, so I'm going to remember IV means 4. Okay, this is where the x is positive and the y is negative. That's quadrant 4. So in quadrant 1, you have an ordered pair. The x is positive, the y is positive. In quadrant 2, with all of your ordered pairs, the x's are all negative, the y's are all positive. In quadrant 3, you have a negative x and a negative y. And in quadrant 4, your x is positive, but your y is negative. Okay? Now, on a quiz, I'm going to ask you to label everything I just labeled. So you have to know this is the x-axis, this is the y-axis, right? You have to know quadrant 1, and then in quadrant 1, your coordinates are positive, positive. This is quadrant 2, and in quadrant 2, your coordinates are negative, positive. This is quadrant 3, and your coordinates are negative, negative. It's quadrant 4, and it's positive, negative. Okay, so all of this is written on page 1, but I did want to go over it. Now, on page 2, it asks us to graph these coordinates. So I want to go over how to graph. So it says graph negative 3, 4. So you always start at the origin. So I start at the origin, I go over negative 1, 2, 3. You always move the x right or left first. So you walk to the elevator before you go up and down. So I go left 3, and then I go up 1, 2, 3, 4. So this point right here, negative 3, 4. And it asks you what quadrant is it in. Well, this is easy because I have it labeled, so this is in quadrant 2. Now I am to graph 5, 0. I'll do 5, 0 in blue. So I'm going to go over positive 5. 1, 2, 3, 4, 5. And I'm going to rise nothing. So this is 5, 0. Now, we do not say this is between quadrant 1 and quadrant 4. we say 5, 0 is on the x-axis. So when a coordinate is on an axis, you just say which axis it's on. Now, letter C, and I'll do C in multicolored, is 0. So I start here. I don't go right or left. I just go down 2. So this is 0, 2. And this is on the y-axis. So what does this point and this point have in common? They are both on an axis, and they both contain a 0. So whenever a point contains a 0, it's either going to be on the x-axis or the y-axis. Okay, D is -3, -2. So I go over 1, 2, 3, down 2. So this is -3, -2. And 5, 2, I go over positive 1, 2, 3, 4, 5, but I go up 2. And oh, sorry, it's -2. So I go down 2. So this is 5, -2, and that's in quadrant 4. Okay, so hopefully everybody remembers how to graph. You will have some practice graphing, but you do need to know the coordinate plane and how to graph. Okay, so now let's turn to page 3. And on page 3, we go over some input-output tables. Okay, so X is your input, Y is your output. Okay, so this says you have X values of 1, 2, 3, 4, and Y values of 5, 10, 15, 20. Okay, and this is on page 3. Now, certain vocabulary you have to know for this chapter. This is lots of math vocabulary, but this is not math vocabulary you're going to use today and never use again. You're going to use this all throughout high school math. Okay, all of your X values, the set of all your input values or your X values. Remember, input is the same as X. It's also your independent variable. Okay, these are terms you have to know. All of your X values together is called your domain. So the domain is all of your X values. The range is your Y values. And we remember that because they both have tails. So your Y values are your output values, and they are your dependent variable. Okay, so you have to know domain and range. Domain is all the X values. The range is all your Y values. Now, when you have a pair of X and Y values, that is a relation. A relation, you should add this to your notes underneath function. A relation is a set of ordered pairs. Okay, that's what a relation is. It's a set of ordered pairs. So write this underneath function on page 3, that a relation is a set of ordered pairs. Now, a function is a special type of relation. A function is where for every input, there's only one output. What that means is this is a function. This is a function because for every X, there's only one Y. This is a function because none of the X values repeat. We will go over functions in a little bit and you will totally understand them. But for right now, just know that the definition is written down. Now, when we look at an input-output table, okay, we know that the input is always X and the output is always y. So if you look at the input-output table here, where it talks about hours and temperature, they want you to list the domain and the range. Okay? Well, we know the domain is all your x or your input. So my domain would be 0, 2, 4, 6. So what do you think the range would be? Hopefully you're all saying 24, 27, 30, 33. So your domain are your input or x's, your range is your output or y's. Okay, so now look at the next input-output table, and it asks you to identify the domain and range, but then it gives you a hint, and it says, when listing the domain and range, do not repeat numbers. Okay, so they give, their input-output table is 0, 1, 2, 4, and they give 5, 2, 2, 1. So my domain would be 0, 1, 2, 4, and my range would just be 5, 2, and 1. Why didn't I write 5, 2, 2, 1? Because it's almost like saying who's in the class, and Bob's in the class. Am I going to say, oh, Bob, Sarah, Jess, Kevin, oh, and Bob are in the class? No, you would never say Bob's in the class twice. You just say Bob's in the class once. Just like I'm not going to say, oh, 2 is in the range, and oh, by the way, 2 is in the range. So when you list your domain and range, you only list the number once. Okay? So look at the next function they give you and list the domain and range. Hopefully you said domain is 4, 7, 11, and 13, and the range is 10, 35, and 45. I didn't repeat 10. I only list it once. Okay, now we're going to go over how to identify whether a relation, which is a set of ordered pairs, or an input-output table, represent a function or not. One of the easiest ways to determine this is to represent your input-output using what we call mapping. Now, mapping is when you have two ovals. You have your input here and your output here. Okay, so let's just pretend I had an input-output table, and this is my input-output table. I have input 1, 2, 3. My output is 4, 5, 5. Okay, so my domain would be 1, 2, 3. My range would be 4, 5. To put this into an input-output table, I write 1, 2, 3, and my output, I have a 4 and a 5. So 1 maps to 4, 2 maps to 5, and 3 maps to 5. And that's how I represent this input-output table in mapping. Now, I could also write it as a set of ordered pairs, and I could say 1 goes with 4, 2 goes with 5, and 3 goes with 5. That's another way of representing my function, my relation, or my set of ordered pairs. Now notice, none of the x values repeat. When none of the x values repeat, that means for each input, there's only one output. What that means is if you put this into mapping, how many arrows are coming out of the 1? Just 1. How many arrows are coming out of the 2? Just 1. How many arrows are coming out of the 3? Just 1. It does not matter that 2 and 3 both map to 5. That's okay. What you can't have is a situation like the next one, which I will show you. So for the next one, here is your input-output table. I have 4, 5, 5, and 1, 2, 3. So my domain is 4, 5. My range is 1, 2, 3. If I show this in mapping, I have 4, 5, 1, 2, 3. 4 maps to 1, 5 maps to 2, 5 maps to 3. Now, let's look at what happened. We see an x value repeats. When an x value repeats, it's not a function. If you look at mapping, there's 2 arrows coming out of the 5. That's not a function. So a function is when for every x, there's only one y. For this particular x, how many y's are there? 2. So it's not a function. Okay, if I was to write this using set notation, 4, 1, 5, 2, 5, 3, I notice, x repeats, not a function. Okay, so let's turn the page, and we're going to try to determine whether these are functions or not. Okay, so for the first one, I have 4, 8, and 2. Notice only one arrow's coming out of each. So this is a function. So how could I write this function as a set of ordered pairs? They don't ask you to, but let's just go over that. I could write it as 4, 1, 8, 2, 2, 3. These represent the same thing. Notice none of the x's repeat, so this is a function. Let's compare that to the next one, 3, 6, 5, 2, 4. 2 arrows come out of the 3. This is not a function. It's not a function because 3 maps to 2 different y's. Okay, so for every x, there's not one y. I could write this using set notation, 3, 5, 3, 2, 6, 4. It's not a function because x repeats. Okay, now let's look at the next one. They give us a table, and if you look at that, this is not a function. It's not a function because 2 maps to 2, but then 2 also maps to 4. So the 2 repeats, and it's mapping to 2 different y's. So that's not a function. Let's look at the next 2. I see 5, 5, 10, 15. It's not a function because x repeats, not a function. For the next one, it's 0, 4, 12, and 20. None of the x's repeat, so this is a function. Okay, so now that we understand what's a function, what's not a function, we're going to learn how to create an input-output table. So to create an input-output table, you need to be given a rule. In this case, the rule is y equals 3x. And they give you a domain, 0, 1, 2, 3. So what you do is you write an input-output table. You write your rule, y equals 3x. For x, I write 0, 1, 2, 3. Now, I apply the rule to get my y value. Y equals 3 times 0, because in this case, x is 0. 3 times 0 is 0. For this one, y equals 3 times 1, so this is 3. For this one, y equals 3 times 2, so this is 6. For this one, y equals 3 times 3, so this is 9. So my range, it asks us what's the range here. My range is 0, 3, 6, 9. How did I get that? I plugged x in for each of these to get my y. Okay, so now you try to do the next one. They give you a rule. The rule is y equals x minus 3, and they give you a domain. So I plug in values for my domain, and I say this is 12 minus 3, which is 9, 15 minus 3, which is 12, 22 minus 3, which is 19, 30 minus 3, which is 27. So the range is 9, 12, 19, and 27. Okay, so I'm going to stop this video now. There'll be another video for page 5.